Okay, so turn around. 1, 2, 3.
Hello, and welcome to our Gummy Bear Sacrifice. Today, we'll be reacting potassium chlorate with a gummy bear containing sucrose, or sugar, in what is called our Gummy Bear Sacrifice. Here's a breakdown of the reaction. Look at this graph!
To begin with, it is important to know that this reaction is a rapid oxidation reaction where molten potassium is a strong oxidizing agent. Within this reaction, there are two reactions taking place, one of which is the redox reaction of the potassium chlorate decomposing into potassium chloride and oxygen gas. The second reaction is the combustion reaction of sucrose and oxygen yielding carbon dioxide and water. But how exactly do we know that these are combustion and redox reactions?
Well, to begin with, a combustion reaction takes place when hydrocarbon reacts with oxygen gas to yield carbon dioxide and water, which is exactly what the combustion reaction of sucrose entails.
Then there's the redox reaction. A redox reaction occurs when there is an agent being oxidized and another agent being reduced within the reaction. That is to say that the agent being reduced will start out as a reactant with a certain number of charge, and the reaction proceeds, the agent will gain electrons, which will show up in its individual charge in the product.
Similarly, the agent being oxidized will start out as a reactant with a certain number of charge, but then as time goes on and the reaction proceeds, the agent will be losing electrons as shown by the individual charge of the products. But how do we check this? First, you will start with your overall reaction. As we know, all ions have charges. Anything in its natural state automatically has an assigned charge of 0. We will now begin with something that is called an individual/total charge. We would recommend first starting with writing the overall charge of each compound, which will typically be indicated. Then write the charges of the anions within each individual compound. Multiply that by the number of anions there are of that specific anion. Do the same for the cations, but with the intent of being able to add their charges with the charges of the anions in order to equal the overall charge of that individual compound. Do that for all individual compounds within the reaction.
Once you have completed that step, it's important to note the difference, if such, in the charge between the reactant side and the product side of the initial charge of each individual agent. An easy way of remembering what has oxidized and what has been reduced is to remember the saying of Leo, the lion, says grr as in roar.
Roar.
As was explained before, whichever agent loses electrons is oxidizing, and whichever agent gains electrons is reducing. In order for there to be a redox reaction, you must have both oxidation and reduction occurring. In the case of our experiment, potassium loses electrons and oxidizes, while chlorine gains electrons and therefore reduces. Now that we know our reaction is a redox reaction, it's time to learn the science behind sacrificing gummy bears.
In our reaction, when the gummy bear is dropped into the potassium chlorate that is molten, it will quickly heat up and start to melt. The melting sugar is now exposed to large amounts of oxygen from the molten potassium chlorate, and a combustion reaction starts. This is the flame/sacrifice you see. This, in turn, creates more heat, causing the reaction to happen even faster as more oxygen is released, more sugar is burned, and more calories, heat energy, are released from the test tube, which is the cool part. This reaction is exothermic, meaning that heat is released. This can usually be predicted by whether or not you can feel heat around the system. In our case, flames may protrude from the vessel. Now, without further ado, it's time to watch the magic happen. For this experiment, you're going to need potassium chlorate, between 6 and 7 grams of it. You'll need this bad boy, the scale, to weigh her out. And you will need, that's not a thing, you will need a weigh boat to put it into, because that's how we do things. Make sure you zero the scale. Next, let's go over here. We need gummy bears. You have to make sure that they have sucrose. These have 31 carbs in it, so I'm gonna assume it's sucrose because that's how carbs work, right? Oh, sugar is 19 grams, great. Sugar. Then you're gonna need this bad boy for the Bunsen burner, so you can light her on fire. You also are gonna need gas, which is this bad boy, to give the Bunsen, Then you need tongs. You need these to place this bad boy, which is the gummy bear, into the test tube, which is also what you'll need. You'll need a large test tube, a clamp for your ring stand, and a ring stand. And the fume hood, of course, obviously. Safety is first, so that's what you'll need for this experiment.
And your lab goggles.
Oh, and your goggles and your hair tied back, of course. Safety is first, right?
Science.
Okay guys, so the first thing we're gonna do is take this potassium chloride that we mentioned before and weigh up 6 to 7 grams. So that's what I'm doing under here with this thing and my weigh boat. So yeah, make sure you zero it. It's super important. So then you're gonna just all right, perfect. We have 6.27 grams of potassium chloride, which will work perfectly. So next, you're gonna need a large test tube. Here's a hand for scale. Yeah. So then what you're gonna do is you're gonna take this glass bad boy, and you're gonna put it in. Yeah. Oh, you got this. You got this. You're gonna take this, and you're gonna put it. Ooh, that was a screech into this. And yeah, that's how we're gonna do that. Oh my god, you have to do it, Emma.
We'll be back in a second. All right, we got it.
The next thing we're gonna do is take this 6.27 grams of potassium chlorate, put it into this bad boy, because like it'd be like that.
So now we're gonna take this
ring stand here.
over.
Oh, I'm so in the way. I'm sorry.
Over. Hi, Missoula. Hi. Here in the fuel hood.
Test tube.
We're gonna make sure that the test tube
is pointing up and away from our faces, so it's not quite, away. So the sacrifice doesn't get to us.
All right.
So. Alright, off to the gum. Do you want me to go? Yeah, you're doing. This bad boy, the yellow ones are the worst.
Wait. Oh, my finger's stuck. No, do not. That is so cool. Oh, there she goes. That is so cool.
Okay. So we're still spinning. All the good stuff. Oh my god, it looks spit it out.
Wait, what?
Did she spit? Can I push it in? No.
No, it's... Well, you can, but how?
Hit it with the tongs.
Not like that. But I think we've already...
Because it goes for a while.
Yeah, you're right.
I think, but it would have solidified it this way.
Oh, really?
Yeah, see, this is
Yeah,
solidified.
it's done. Look at it, it's like... There's like
Careful. Now, this one I tried. You guys
I spit it out.